Alright, so let us talk about single-stage equilibrium contact for vapor-liquid systems. So, tignan natin itong diagram natin dito, no? In here, we have a single-stage equilibrium process wherein itong ating V2 is a vapor and our L0 is a liquid. So, in this case, these two streams are brought into contact in a single equilibrium stage as presented in our diagram. So in this case, our boiling point or the XY equilibrium diagram na pinakita natin in our previous lecture should be used because an equilibrium relation that is similar to Henry's law is not available. So since in here we are only considering two components, so katulad ng mga napag-usapan natin previously about binary mixtures, so there are only two material balance equations that we will be using. But first, let us identify yung mole fraction ng ating, let's say, more volatile component or component A dito sa ating mga streams. So, for the vapor, our mole fraction is represented by Y. Okay, so in here we have Y2, and for this stream V1, our mole fraction is Y1. Now, for the liquid phase, our mole fraction is represented by X. So, in here we have XO, in here we have X1, okay? So, ang X natin is mole fraction in the liquid and Y is the mole fraction in the vapor. Okay, so again, meron lang tayong dalawang component dito, component A and component B. So, meron lang tayong dalawang material balance equation na gagamitin. So, first is yung ating overall material balance. So, we have the two streams entering. We have V2 plus LO. Ito yung mga pumapasok sa atin. L0, which is equal to the streams leaving. So, we have V1 plus L1. Okay? So, this will be equal, no? Yung pumapasok at lumalabas are equal. Now, based sa ating more volatile component balance, we will have our V2 times Y2 plus for our entering liquid, we have L0 X0 is equal to the leaving stream, which is V1 Y1 plus for our leaving liquid, we have L1 X1. Okay, so ito yung mga material balance na gagamitin natin for a single stage equilibrium contact for vapor liquid system wherein we only have two components present. Alright, so meron tayong tinatawag na constant molal overflow. So if the sensible heat effect are small and the latent heats of both compounds are the same, then when 1 mole of A condenses and 1 mole B must vaporize. So therefore, our moles of V2 is equal to moles of V1, and similarly, our moles of L0 is equal to L sub 1. Alright, so these are the things that we will be considering if we have a constant molal overflow. Alright, so in order to understand how do we apply this, let us solve the problem below. So we have two components here, which is a benzene-toluene mixture. Okay? A vapor at the dew point and 101.32 kilopascal containing a mole fraction of 0.4 benzene, component A, and 0.6 toluene, component B, and 100 kilogram mole in total is brought into contact with 110 kilogram mole of a liquid at the boiling point containing a mole fraction of 0.3 benzene and 0.7 toluene. The two streams are contacted in a single stage and the outlet streams live in equilibrium with each other. So, ito na nga yung topic natin. No? Single stage siya and we are having an equilibrium contact, no, in our vapor and liquid. So, assume constant molal overflow. So, ito na yung binasa natin just a while ago. And calculate the amounts and composition of the exit streams. Okay? So, para mas madali natin siyang ma-visualize, let us draw muna yung ating situation in here, no? So, let's say, ito yung ating process. And then, may pumapasok tayong liquid and vapor. Okay? So, And dito naman yung lumalabas na vapor at dito yung lumalabas na liquid natin. No? Okay, so gamitin na rin natin yung mga variables na kanina ang ginamit natin. So, for our entering liquid, we have L sub 0. And for entering vapor, we have V sub 1. And for the leaving vapor, we have V2. And for the leaving liquid, we have L sub 1. And similarly, our mole fraction here is Y1 for the vapor, Y2 for the vapor. And for the liquid, we have X sub 0 and X sub 1. Alright, so katulad nung binanggit natin kanina, no, we will be using two material balances lang naman dito. But in this case, we will just be using yung component balance natin, no, considering yung ating one of the components. No. So, let us have our entering liquid LO, then the mole fraction XO, plus V1 Y1 is equal to L1 X1 plus V2 Y2. So, identify muna natin yung mga given values natin para mas madali natin siyang ma-solve, no? Hindi tayo malito. So, alam natin, our condition here is at 101.32 kilopascal. So, katulad nung sinabi ko kanina, when we have a problem like this, we will be using itong XY diagram natin. Okay, so kaya pinrepair na natin siya dito. Okay, so this is the XY diagram of benzene-toluene at 101.32 kilopascal. Okay, so a vapor, okay, vapor ang tinutukoy dito, entering our system here with 0.4 benzene, no? So that means our Y1 here is equal to 0.4. And then our other component, which is component B, toluene, is 0.6. So, yan lang ang kailangan natin for now. And then, the total of the entering vapor is 100 kilogram mole. So, this is 100 kilogram mole. Alright. And then, it is in contact with a liquid. Okay, so liquid naman ang tinutukoy natin. At the boiling point containing a mole fraction of 0.3 benzene. So, ang XO natin is 0.3, no, ng benzene. And 0.7 toluene. And then, given din ang kanyang total kilogram mole, which is 110. So, our LO is equal to 110 kilogram mole. Okay? Now, the two streams are contacted in a single stage, and the outlet streams live in equilibrium with each other. Okay? So, we have an equilibrium contact system in here. Assume constant molal overflow. So, ito yung pinag-usapan natin kanina. No? Sabi natin, if we have a constant molal overflow, our V2 is equal to V1 and our LO is equal to L1. So, in that case, since LO is equal to L1, that means our L1 is also equal to 110 kilogram mole and our V2 is also equal to 100 kilogram mole. Okay? So, now we can substitute these values dito sa ating equation ng material balance. Ano? So, our LO is equal to 110 times XO, our mole fraction, which is 0.3, plus V1, our V1 is equal to 100, times Y1, which is 0.4. Okay? And this is equal to our L1, okay, which is also equal to 110. And we do not know X1, so we will be writing X1 here. Plus our V2, which is 100. So, 100 times our Y2. Okay, so let us be reminded that ang kailangan nating makuha is yung the amount and composition of the exit streams. So, ang kailangan nating makuha is ano ang value ng X1 and Y2 in our exit streams which are in equilibrium. Take note of that. Alright, so we will be using this graph, okay, katulad nung sinabi ko kanina, na itong ating table here. But we will not be able to easily identify dahil parehong X and Y ang unknown natin in this case. So that means we will be using trial and error on this type of problem. So, para mas mapadali, isolve na natin itong nasa left side ng ating equation. Okay, so let's use our calculator. We have 110 times 0.3 plus 100 times 0.4. So, this is equal to 73. So, that will be on the left side of our equation. So, we have 73 is equal to 110 times x1 plus 100 times y2. Alright, so we will do trial and error in here. So, katulad nung binanggit ko kanina, we will be using our XY diagram in here. So, if we are going to do trial and error, we can assume any value na nandito sa ating mole fraction in our liquid, no? Which is XA. So, let me try using 0.2. So, this is a trial and error, so you can assume any value here. So, I will assume let our x1 is equal to 0.2. No? So, ito muna yung i-assume ko na value, 0.2. So, we can use this equation right here. So, para nga hindi tayo malito, let me name this as equation 1 na. Okay? So, I will be using equation 1. So, ibig sabihin, I will substitute itong value ng x1 dito. Then, I will be able to find yung value ng y2. Okay? So, let me substitute that here. I will have 73 is equal to 110 times x1, which is 0.2, plus 100 times y2. Okay? So, I will be able to calculate for the value of y2 in here. y2 is equal to 73 minus 110 times 0.2 divided by 100. Okay, so our y2 in this case is equal to, again, let us use our calculator, 73 minus 110 times 0.2 divided by 100. Alright, so our answer here for our y2 is equal to 0.51. Okay, so let us find that dito sa ating XY diagram. Okay, so we said that our x sub 1 is equal to 0.2, and then na-calculate natin na y2 is equal to 0.51, which is somewhere in here. Okay, so let us graph that. Alright, so it is somewhere in here. Okay, so as you can see, nasa labas siya ng ating curve, no? Ito yung ating curve. So, ang kailangan kasi nating makuha, ano yung value natin here in the curve. Okay, so remember that our exiting stream, yung vapor and liquid, are in equilibrium. So, therefore, dapat ang maging sagot natin dito falls dito sa ating equilibrium curve, no? So, dapat nandyan yung sagot natin because nasa equilibrium sila. So, yun yung hahanapin natin. At what point our x1 and y1 are in equilibrium, that will satisfy our material balance right here. Okay, so dahil nasa labas siya ng curve, this is not the answer that we are looking for. So, again, this is a trial and error. So, let's see, I will use 0.4 now kung saan siya magpo-fall. So, I will let x, okay, sub 1 is equal to 0.4. So, I will have, again, 73 is equal to 110 times our x1, which is 0.4, plus 100 times y2. Okay, so I will not write further itong ating katulad ng ginawa kanina. I will just solve y2 directly using our calculator. Okay, so we have 73 minus 110 times 0.4, then divided by 100. Okay, so I have 0.29 in here. Okay, so let us now plot this. Hanapin natin kung nasaan siya dito sa ating XY diagram. So 0.29 is somewhere here. Okay, and then we have 0.4. Okay, so align natin siya sa 0.4. So it is somewhere here. Alright, so this will be our dot. Now, this is still outside our curve, no? So, let us try 0.3. Then, tignan natin kung saan siya magpo-fall. So, let x1 is equal to 0.3. So, tignan natin kung saan mapupunta if we use 0.3. So, we have 73 is equal to 110 times 0.3 plus 100 times y2. So, I can solve for y2. Okay, so again, using our calculator, we have 73 minus 110 times 0.3 divided by 100. Right, so now I have here 0.4. Alright, so ilocate natin uli siya dito sa ating graph. So 0.4 ang ating y. So it is somewhere here. And then our x is 0.3, which is somewhere here. Okay. So, nandito naman siya sa gitna ng dalawang points natin. No? Remember, ang kailangan nating makuha is yung value na nasa curve. So, if we draw a straight line dito sa ating mga nakuha na values, okay? If we draw a straight line here, okay, so medyo hindi lang tayo nagsasakto because we didn't really use a ruler, no? Kailangan kasi natin gumamit ng ruler dito para masigurado natin na straight ang ating mga lines at makuha natin yung exact value. Now, ang kailangan nating makuha is yung intersection ng ating line at nitong ating curve, which is right here. Okay? And with that, we can get the value of x and the value of y. Okay, so from here, let me get the value of our x, which is right here, no? So, it is at the middle of our 0.2 and 0.3. So, we can say, let us say this is 0.25. So, x1 is equal to 0.25. So, our y is also expected to be somewhere in here. No, sa pagitan ng ating 0.5 and 0.4. So, because we are not scaled, so let me say this is around 0.45 na lang. 0.45 for our y. Y2. Okay? So, tignan natin kung magmamatch ba yan dito sa ating equation, ano, para makasigurado tayo. So, I will use x1 as 0.25, then substitute that here. So, let x1 is equal to 0.25. So, I will have 73 is equal to 110 times 0.25 plus 100 times y2. So, our y2 must somehow match yung nakuha natin because we are not exact dun sa value natin, ano? Because we did not use a ruler and this is not, it is not scaled. So, we will get our y2 in here. So, our y2 is equal to, again, 73 minus 110 times 0.25 then divided by 100. Our answer here is 0.455, which is close dito sa ating nakuha dito, no? 0.45. Okay, so that means that is our answer in here. We have our x1 is equal to 0.25. So we did trial and error dito sa ating solution para makuha natin yung composition na hinahanap natin in our exiting streams. Okay, so I hope guys that you got itong pinag-uusapan natin ngayon about single-stage equilibrium contact for vapor-liquid systems. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.